degrees centigrade. The different materials will be having a different temperature for printing. Okay, the PLA whatever we have here, this will be printed at 210 degrees centigrade. And this is the bed. This is the stainless steel, spring steel, which is powder coated. This is where the print is going to stick on the part. And we also have at the bottom of this, we have a silicon heater, which heats up this aluminum plate. This is how this heat is transferred onto the spring steel plate. So usually the temperature for printing PLA of the bed will be 60 degrees centigrade. So what happens now is, as soon as in this, it's a very simple process to start a print. You have to just go, scroll down to the bottom. We have a print from media. Just select print from media. The part whichever we have slides there, it will be on the top. You just select it on print. Now the machine started heating its bed. Now this is when first layer of the print will be 70 degrees centigrade, and then once the first layer has been printed, the temperature goes down to 60 degrees centigrade. And once the bed is heated, then the temperature of the nozzle will be heated to 210 degrees centigrade, where the filament goes and pops out. And if you guys are really interested, I can show you how. I'll remove this and show you how exactly the filament goes in and extrude on the bottom. You guys are interested to see? Yes. So, do you guys know what is this? Good. And we have a M4 bolt at the bottom. So if you guys are really interested, I can rip off the machine and also show how exactly we build the machine. You guys are interested? Yes, sir. You want me to do that? Yes, sir. I will do it. Yeah. This is actually the heart of the machine. So, if you guys can see here, this is a hobgoblin. We call it as a hobgoblin. And this is the extruder motor. This is the one which drives the extruder gear here. And there is one more extruder gear here on the arm of the machine, arm of this. So what does this do is push the filament from top, grind it across these gears here, push it onto the nozzle. So if you can see here, there will be a PTFE running. As you can see here, this is called the PTFE at the top. This white color thing is there, no? This is a PTFE. That will be, outer dia will be 4 mm, inner dia will be 2 mm. So this is pushed onto the PTFE inside this 2 mm hole, and that is passed on to the heatsink. The heatsink is the part where it will be always cool. So we have a 30 mm fan over here, which will be always keeping our nozzle cool, but not the heating cartridge. Heating cartridge will be always high temperature, that is 210 degrees centigrade. And as soon as the motor drives the hob, this pushes the filament onto the nozzle here. As it's already at the 210 degrees centigrade, it pushes the filament at the molten temperature. It will be in the molten state and push it on outside of the nozzle with the diameter of the filament which comes out of this will be 0.4 mm. And we also have the cooling fan here. If you guys can see, there will be a cooling fan over here. This cools the molten material which comes out of it. As soon as it sticks onto the bed, the molten material will start cooling, so that when it goes to the next layer, it will be at the cool temperature. It will be solidified, so that the next molten plastic will be on the next layer. That's how the printing happens on this. So in this 3D printers is the most simple machine you can ever see in mechanical engineering. It's not complicated like CNC machine or other machines. So we will be having 4 motors here. The one is for moving the XY in this direction. The one will be in this bottom, which will be moving in front and back direction. And one will be at this bottom, which moves the carriage up and down, that is Z movement. Okay. So in this, as you have already seen, this is the heart and this is the structure of the machine, and the brain will be at the bottom of this. So I can show you the brain also. Guys, have any doubts till now? You want to know anything more about this?
And we print using steel, aluminium. Yes or no?
Yes, sir.
Yes, steel.
No, sir.
Why? Without doubt, you ask what is the maximum temperature as on today is possible. So increasing temperature is the challenge.
So this is the brain of the machine. We have MKS board. This is where all G codes will be stored onto, and this is how it has been passed. This signals the motor how much to move and rotate. So this is the main part of it, and this is the SMPS which gives the power to the system, and we have one relay which switches off the heating and closing section. Like if the temperature goes to the temperature what we need, then it tells the signal that switch off, that it will switch off. When it goes lower, it will tell so switch on, it will switch on. That's how it's going to help us. And here we have a load cell. Have you guys know what is strain gauges? Strain gauge rosette have you used? This works on the same principle. So this is called a load cell. So what we have done in this is to make the level flat, to make the bed flat while printing. What we have is a load cell. If you guys can see, we have used a fulcrum concept. So there is a cutout here. So the whole bed is mounted onto this plate, where the cathode is there, and we have mounted the load cell from here to here. So whenever the nozzle comes and touches the bed, there will be a deflection. This deflection is noted by the load cell here. So the deflection, whatever it shows, that will be in the resistance. That gives a spike in the system and tell that this is my position where I am getting the spike. So what happens is that is stored into our brain. It's stored into the brain and tells this is my point. So then it goes to the next point. There it again strikes the point and tells, so this is my point. This is where the spike is happening. So it makes sure that everyone on the same line. So that's how the bed will be flat. Only when the bed is flat, only you can print the parts. Or else if there is any deflection in the bed, the part will not stick onto the bed, so that will warp, and that will be destructive. That will be waste of the part. So that's how this load cell is helping. So this is the very simple, as you guys can see, this is very simple. 3D printer is the most simple and most innovative and most useful machine you can ever use. So this is the concept, as you guys can see. So you can start. And how many of you have ever removed a machine and checked what exactly it works? Any guys here around who never tested how to remove a machine? Have you ever spoiled your refrigerator and tried to, you know what? Yeah, removing is a good thing. That's how you guys understand. You know Elon Musk, right? You guys know Elon Musk? The first question in interview you'll ask is, what have you done? What have you removed the machine? How have you solved the problem? That's how he's going to hire you people. So as a mechanical engineer, first thing you have to have in your pocket is Allen keys or screwdriver. Whichever machine you want to try, remove it off, rip it off. Just see if you spoil, that doesn't matter. That's how you guys learn. That's how we also learned. When I passed out in 2012, I was not like, I was now one. So I also started learning by opening the machines and understanding how exactly it works. That's how we came up with this idea also. You know, the CEO of my company is like, when we started the company, he was 21 years old. So say me and he was in the same age group. So that's how companies are started. So I don't want you guys to compete for this small corporate job. Never go to software job, guys. I'm telling you. That's the worst thing you can do. If you earn 10,000 also, it's better if you work in mechanical industries. I request you guys, never go to the software field. It's the worst thing you can see. You'll always see the black screen. That's not how it works. As you can see, the software I was working on, it's a SolidWorks. How colorful and how beautiful it is. We are the engineers. We are mechanical engineers. We can be a software engineers, but software engineers can never become a mechanical engineer. So always go to the core companies. That's my only request. Please don't go to software companies. Sit. That's the worst thing you can ever do for yourself. So you can never understand what I have some case studies also. I will show you like how much mechanical engineers are helping the world to solve their problem. So we'll start a print. Is there any doubt, or you guys need anything more clarification about the machine or anything? It's fine. You understood? What? Accuracy is 100 micron. 3D printings, FDM machines will have 100 micron accuracy. So there is other technologies like SLA, SLS that can go up to 50 micron. So our printer will give you 100 microns. That is more than enough for all the prototyping and others. So 100 microns, you can, if we go with 100 micron resolution, whatever I told you, that can give you like 50 microns, but 100 microns is what we sell. How many of you are placed already? Okay. You guys all are 6 semesters. Okay. So I'll show you some other options how this works. So we have an option called motion. If you go to this option called auto home. Auto home is the home position of any component. Like for this now we have a limit switch over here. Limit switch is the point where it triggers and tells this is my point. Okay, if you guys can see, it's moving up. The first thing is always whenever machine switched on and tell auto home, it will go to the upstairs, that moves up and triggers at a point. So now it triggered and told this is my home position. Now this is the 0, 0 for Z. So this is the 0, 0 for X. And this moves back and triggers until this is the 0, 0 for my Y. Okay, that's how, now it is 0, 0. It's at 0, 0 position. So when the nozzle is exactly at the 0, 0 position, and this can move 200 back side, 200 front side, 200 at the top bottom. Okay, this is 200 belt size. This is how we calculate 200 belt size. Okay. So we have an option called change filament. If you go to change filament, so we are printing in PLA. Just select pre-heat PLA. The bed comes out. Now the nozzle temperature is going up to 210 degrees. What is the diameter of this filament? 1.5. If you guys want to have a touch and feel of the machine, you guys can use it. So now the going to 110. 210 is the treated temperature. Do you guys have any projects in 6th semester? You guys do? What have you guys done? Any innovative products you have done? You girls there? So quiet. Have you done any projects?
Not yet, sir.
You have to do in 6th semester.
In our department, 2 batch students, they created 3D printing machine. So that interest should be there. What Parag told, you want to get core company, if you simply sleeping, you will never get even rating. If you get prepared, if you have the skills required for core company, then you will get core company. So Bharat, Akash and others, if they go to any company, core company, definitely they will get the job. Latest technology, whatever latest technology, you have to update yourself, both knowledge and skill. Then it is possible.
So now I am facing a problem. Please. So now I am facing a problem. So I am trying to solve it. So problems are always good to mechanical engineers. What are the subjects you guys have in 6th semester?
International.
Design 2 or 1?
Design 2.
What is the designs you guys do there?
Spring, gear, clutches, brakes.
So see, this is the gear I was talking about. So what does it do is, the filament comes from the top, goes through this hole. Can you guys see this marking here? This is where the puncturing of the filament happens. So we have one more gear here. So this gear is driven by the motor. This gear drives this gear. And whenever this starts moving, the filament from the top is pushed against this hob and push it onto our nozzle. That's how it's going to work. Okay, this is a very simple thing. By that time Alan Key comes, I'll show you some case studies so that you can understand what are the problems we are solving. Okay? You guys can sit around. If you guys have any idea and you guys want to test and feel the machine, you can guys are free to come and do it.
Keep it.